So for my math team students, we are going to quickly talk about the unit digit of a number when it's raised to a large power, and then how to find that. And so the key point that we need to remember in this is to find the unit digit of a number raised to a large power, identify the cyclicity of the unit digit, and then find the remainder when the exponent is divided by the cyclicity. And what this actually means is, like, if you're looking at these numbers here, and then I am trying to see, okay, what would that units digit be? And we need to use the fact that unit digits are recurrent in powers, okay? So these are the numbers that I have just put over here. And then, we're going to solve this and see how simple it is. And 3 to the 26th power means what? 3 times 3 times 3 times 3 times 3, and like that goes on 26 times, right? But we are not going to do that because it's just going to take forever. So all it's asking is, what is in the units digit of a number? So we're talking about, the ones place value, which is at the end, okay? So let's look at 3 to the 26th power. And I know, I'm just going to show you the visual. So I know that 3 to the first power, any number to the first power is the number itself. So this is 3, okay? 3 squared is 3 times 3, which gives me 9. 3 cubed is 3 times 3, which is 9 times 3. That gives me 27. 3 to the fourth power. So that means the 3 cubed was 27. And then another times 3, I'm going to get 81. I'm just going to give you this example, okay? Then if I do 3 to the fifth power, 81 times 3, and I'm going to get 243. And 3 to the sixth power, I'm going to get 243 times 3, and I'm going to get 729. 3 to the seventh power, 729 times 3, and I'm going to get 2,187. And then if I do that times 3, which is 3 to the eighth power, I'm going to get 6,561. And then this pattern continues. So when we are trying to find the units digit, we just need to know that what is the cycle of the pattern. So if I'm looking at 3, look. So we have 3971. 3971 in the units digit, and then this pattern continues, okay? So basically, what is this cycle of? Cycle is of 4 numbers in this case, which is 3971, 3971 constantly. So all that we do in this case, because we know that it's in that pattern, that the digits are continuing, so I'm going to take 26, which is my exponent, and I am going to divide this by the cycle of 4. Okay? So look, and then you're going to find the remainder, and that's what we were talking about. So 4 times what? 4 times 6 is going to give me 24. Okay? 4 times 6 is going to give me 24. What is my remainder? 2. So this is what I'm looking at. So since it's 2, I look at the second number, 1, 2. If the remainder was 3, I would look at 7. If the remainder was 4, I would look at this. If the remainder was 1, I would look at this. So in that cycle of 4, in that pattern, my remainder is 2. So guess what? My units digit is going to be 9. Okay, because that's the second number in the pattern, since the remainder is 2. So this is for 3 to the 26th power. Now, if I look at 13 to the power of 131, you will notice that 13 also follows basically the same pattern as 3. Okay, so this also follows exactly the same pattern as 3. Okay, so again, because look at this, 13 to the first power, I get 13. All right, 13 squared gives me 169. So look, this pattern starts even with this one. Just because I have that 3 in the end, I am going to get exactly the same pattern even for 13. All right, so the pattern of 4 numbers repeating with the, the 3, the 9, the 7, and the 1. So these 4 units digits are repeating even in 13. All right, so that is why if I am getting that, and we know that what the unit digits are, so I'm just going to take the 131, okay, 131, and I'm going to divide it by 4 because that pattern of 4 is continuing even for 13. All right, and so we see that here we go, 4 times 3 is 12, okay, and I get 1 remainder and I bring this down, okay, and then I know that 4 times 2 is 8 and I get a remainder of 3, okay, and since I get a remainder of 3, what is the third number in the pattern? 397. So 7 is the third number in the pattern. So therefore, this one, the units digit in 13 to raise to the 131st power, the units digit would actually end at a 7. All right, and that's basically how I find this. Let's do the next one. Let me erase this, and let's do the next one. And that one, okay, hold on. So this was 13 to the 100. Okay, so let's do 2016 raised to 2016. All right, so let's do this one. And if I look at this, if I have 6 to the first power, so let's just look at this one. Okay, over here I was looking at the 3 and the 3. All right, so if I look at 6 to the first power, I get 6. 6 squared. That means 6 times 6 is going to give me 36. All right. 6 cubed. 36 times 6 is going to give me 216. Okay. And then 6 to the fourth power is going to give me 1296. So if I'm looking at the pattern for 6, it always ends in a 6. It always ends in a 6. So in this case, if I have 2016 with an exponent of 2016 or power of 2016, guess what? It doesn't matter whatever, because this is always ending in a 6. So it would be 6. The units digit would be 6. That's as simple as that is. Okay, and now let's look at this one, all right, which is 4 raised to 2024. Okay, so we need to look at what is the cyclicity of 4. Okay, so if I look at 4 to the first power, I'm going to get 4. Okay, 4 squared means 4 times 4, which is 16. 4 cubed, that means 4 times 4 times 4, and that gives me 64. 4 to the fourth power, and that is 64 times 4. So that gives me 256. So now let's look at the cyclicity of this. Okay, we have 4, 6, 4, 6. And that pattern is continuing. So basically, it's a cycle of 2 numbers, right? So I am going to take 2024 and I'm going to divide by 2, okay? So I'm going to divide 2024 by 2 because we are having a cycle of 2 numbers. Now just looking at 2024, I know it's an even number, so I'm going to have no remainder, okay? So ultimately, I end up with 1012, and I know that if I had done, this, I would get 0 remainder. Okay, and since the cyclicity is of 2 numbers, either I can have 1 remainder or I will have no remainder. So that means it would be the second number, which is what? 4 squared. Okay, 4 squared, which is 16. So what is it ending in? The units digit is 6. So if I have anything like that, that's basically what I'm going to solve. Okay, 4. So once again, it is very easy. All you're doing is looking at the pattern. Let's say I have 5 raised to certain thing, is always going to end in a 5. So that would have been my units digit. It doesn't matter. Okay, what it is. And then if I have 4, it's always going to end in a pattern of 2. All right, in 6, it's always ending in a 6. In a 3 or 13, it is ending in a cycle of 4 numbers. And, we had already discussed that, what those numbers are. And again, for 3, it's going to be 3971, 3971. So that is how the units digit is ending. So you all just have to come up with a pattern as to what those numbers are cycling as, and then you take the exponent, you divide it by that number, and whatever the remainder is, that is whichever number that is in the pattern, and that's how you figure out what the units digit is going to be. So very simple lesson. All right, have a great day, guys.